have a classic word problem. The biggest challenge most of the time is to figure out what's being asked. So we read through, we mark it up, and then we get it in our mind what's happening, and then we can solve. So on the playground, a new sandbox is 7 meters wide and 9 meters long. The bottom needs to be lined with plastic before the sand is added. Determine the area of the sandbox to find out how much plastic is needed to be purchased. All right, so now I'm going to go back and circle the important facts. 7 meters wide and 9 meters long. When I see wide and long, I'm already knowing that that's area, or at least I've got a rectangle, because length and width usually refers to a rectangle. So I'm going to go ahead and draw one myself, and I'm going to label it. The long side, the length, is 7 meters. Oh wait, the long side is 9 meters, and the short side, the width, is 7 meters. All right, now I'm going to, what are they asking me? The bottom needs to be lined with plastic. You've got to put a piece of plastic on the bottom before the sand is added. Determine, oh, they told me, determine the area of the sandbox to find out how much plastic is needed. This one's not a question. Usually there's a question at the end. So I'm going to underline this as if it were. Determine, it's telling me what is the area of the sandbox so I know how much plastic to buy. So we keep rephrasing it in my head so I've got it straight. Well, that's area, and I know that area is length times width. All right, so to find the area of this, I'm going to multiply 7 meters times 9 meters. But now I'm stuck because I don't know my 7s very well, and I definitely don't know my 9s yet. So I'm going to do what's called a tape diagram. You can do it for any multiplication problem when you don't know the answer. You always draw the same size thing that looks like a small ruler box. Tape diagrams are used throughout math, anything we're doing in this new math. So I draw it, and I know that I've got to get 7 sections with 9 in each. So I'm going to draw 6 lines to get 7 sections. 1, 2, 3, 4, 5. Oops, I gotta add 1. Now I'm gonna check. 1, 2, 3, 4, 5, 6, 7. Yep, I have 7 groups with 9 in each. Now go ahead and do this. Even though it's painstaking, it kind of reinforces what I'm doing. 7 groups with 9 in each, because that's what multiplication is. Groups with junk inside. All right. And then I think about friendly numbers. Friendly numbers in 3rd grade are the numbers that I easily skip count by. I easily skip count by 2s. I easily skip count by 5s. And I easily skip count by 10s. 2, 4, 6, 8, 5, 10, 15, 20, 10, 20, 30, 40. I've been doing that since like 1st grade. All right, so I'm going to see if I can use one of these friendly numbers, and the highest one I can go, I do first. Can I use 10? Are there 10 boxes? Nope, there's only 7. So I go for the friendly 5. I count off 1, 2, 3, 4, 5. And I write the equation underneath it. 5 boxes with 9 in each. And before I go ahead and do that, I'm going to write the other equation. Over here is 1, 2 boxes with 9 in each. And look at that. I found both of my friendly numbers, which is awesome. So I'm going to skip count by 5s. 5, 10, 15, 20, 25, 30, 35, 40, 45. 5 times 9 is 45. And 2 times 9, I don't have to skip count by 2s because I know my doubles. 2 9s is 18. So this is called the break apart and put back together. So I've broken it apart, but to find the whole thing, I'm going to have to put it back together. So I'm going to add 45 and 18. And I have 8 plus 5. That's 13. I'll write it over there to remind myself. I'm going to drop that 3, which is in the ones. I'm going to hop that 10 because it belongs with the 10s. 4, 5, 6, 63. 7 times 9 is 63. I have got to get 63. And I'm finding area, so it's not meters anymore. It's the square meters inside. Square meters of plastic before I put sand in the pan.